Our assignment, find the solution to this equation, or solutions. There could be two, since this is a quadratic equation. There could be two, there could be one, or there could be zero solutions to this equation. And since I don't have anything simple like 4x squared equals 0, since I have a linear term, which I see right here, negative 7x, that means I'm probably going to have to use the zero product property to solve the equation. In other words, I will turn the left-hand side into two factors and then check each one to see if I can let it be 0. Remember, the zero product property says if I have two numbers, I'll call them A and B, and they have a product of 0, then I know that A equals 0 or B equals 0. They could both be 0. If they're both 0, that's not interesting to us in this problem. In fact, they can't both be 0 in the problem that we're working on, which we'll see soon. Okay, so let us clean this up just a little bit, and we are going to factor our left-hand side. So I think I'll do that over here. Remember, since my A, let's make a list of what my coefficients are. Here are my coefficients. In the left-hand side, my coefficients are A equals 2, B equals negative 7, and C equals negative 4. Notice it is not 2x squared. Notice it is not 7x. The coefficients are constants that are in front of the variable. They are the numbers that the variables are being multiplied by. All right, in the case of A being some number other than 1, remember, we are actually interested in not C, but A times C. And in this case, A times C is 2 times negative 4, and that is negative 8. We are looking for factor pairs of negative 8. All right, well, here we go. What are they? Well, there's 1 and negative 8. There's negative 1 and 8. There's 2 and negative 4. And there's negative 2 and 4. And I can instantly see that if those, remember, those must add up to make negative 7. And since they must add up to make negative 7, then the larger number of the two, the number with the greater absolute value, must be negative. That tells me I don't have to consider the other two pairs. Well, let's take a look at this. We're looking for two factor pairs which have a sum of negative 7. Two numbers that when you add them together, you get negative 7. And I see them right away. Here they are, these two numbers, 1 and negative 8. When I add them together, I get negative 7. Those are the ones that I want. So, I'm going to break my linear term into two terms. My quadratic is untouched. My linear term now becomes 1x and negative 8x. And my constant term is untouched. And I'm going to look at that pair of terms and that pair of terms, and I'm going to find the greatest common factor of each of those. Well, the greatest common factor in 2x squared plus 1x is x. I factor that out. The greatest common factor of the two terms, negative 8x minus 4, is negative 4, leaving behind 2x and 1. Remember, this is all still an equation. I'm still interested in finding the values that make that equation true. All right, so I hope you can see now I have one of my factors will be x minus 4, and one of my factors will be 2x plus 1. So let's rewrite that as factors. I now have x minus 4, and I have 2x plus 1, and still those are equal to 0. All right, zero product property tells me either x minus 4 equals 0 or 2x plus 1 equals 0. Let's solve each of those equations. That was easy. X equals 4. This is our first candidate for a solution. Or, let's see, I'm going to subtract 1 from each side. I'm going to divide each side by 2. And here is my next candidate for solutions. I call them candidates because I'm not sure yet. We're going to decide real soon whether they actually are, because we're going to check those two numbers in the original equation. The original equation was 2x squared minus 7x minus 4 equals 0. I'm going to substitute x equals 4 to find out if it makes this equation true. So everywhere there's an x, I replace it with a 4. And using order of operations, I know that this is 2 times 16. I know this is negative 28. Nice 8. And I know that 4 is 4. 2 times 16 is 32. Negative 28 is negative 28. Negative 4 is negative 4. 32 minus 28 is 4. Oops! I forgot my hypothetical equal sign. We're testing. We're not certain. We can't claim that that left-hand side is equivalent to that right-hand side until we finish testing. And now I'm down here at the very obviously true statement, 4 minus 4 equals 0. So I'm going to put a check mark next to that so that I know that I've checked it successfully. And if I hadn't, I would probably put a not equal through that. I'm going to put a little loopy oval thing around x equals 4 to tell myself that I believe that is one of the solutions. I'm going to start my next check. Remember, I'm going to test 2x squared minus 7x minus 4 equals 0. I'm going to substitute x equals 1/2 in there. So everywhere there's an x, I'm going to substitute 1/2. My hypothesis is that the left-hand expression is equivalent to the right-hand expression. Well, let's start simplifying. 2 times, well, what's 1/2 times 1/2? 1 times 1 is 1, 2 times 2 is 4. So 1/2 times 1/2 is 1/4. Please keep in mind this is not the same as 2 and 1/4. Not the same as that. It's 2 times 1/4. 2 and 1/4 is equal to 2 plus 1/4. They are not the same thing. 7 times 1/2, whole number times a fraction, just multiply the numerator against the whole number, so I have 7 halves, and I have a negative 4 as always, and I am hypothesizing that that left-hand expression is equal to the right-hand expression. 2 times 1/4. If I have 2/4 of a pizza, how much pizza do I have? I have 1/2 of a pizza. I still have minus 7 halves. And I'm hypothesizing that that's equal to 0. And I think I've made a mistake. I have. I want you to notice this. I'm going to just go back and clean that up. That should be a negative number, not a positive number. So everywhere I have a 1/2, I'm going to put a negative sign in front of it. I don't think I'll have to do a whole lot of work. A negative 1/2 times a negative 1/2, well, negative 1 times negative 1 is positive 1, so that one wasn't changed. What is changed, of course I'm going to clean it up in here, what is changed is that I now have a negative 7 halves to deal with instead of a positive 7 halves. Okay, well, 1/2 minus negative 7 halves is the same as 1/2 plus positive 7 halves. I have like terms. I can just add my numerators. So 1 plus 7 is 8. I have 8 halves minus 4, I hope, is equal to 0. And of course, as you recall from elementary school, 8 divided by 2 is 4. I'm going to take out that 8 halves and replace it with the number 4. I think you'll agree with me that it is obviously true that 4 minus 4 equals 0. So I have checked my second candidate, and I believe that is the true other solution to this equation. My solutions are x equals 4 and x equals negative 1/2. I will write those up somewhere in a box where I can find some room. And so my solution is x equals 4 or x equals negative 1/2. This is my answer. There are 2 solutions to this quadratic equation. One of them is 4, one of them is negative 1/2, and there we go. Well, I'd like to let you see this whole paper. It's going to be a little tricky. We'll leave it like that. Thank you for your persistence, patience, and